Hi guys, in this video we will be looking at question 3 MIP 2601 examination. This was October-November 2022, but we are reviewing it in preparation of October-November 2024, right? So how many marks are we looking at? 16 marks. Nice marks, right? So we need to get that beautiful 16 marks. So we need to get that beautiful 16 marks, guys. So I'll show you how you can get that beautiful 16 marks. So the question that I will answer in this question paper, the theory, I would like us to do it personally. You can do theory. You can do question 2, the theory. You can also refer to your study guide as you are reviewing. So as well as question 4, it's the theorem. So some of the question I'll answer them on community in our YouTube channel. So I'll just post them today, so you can so you can refer to them, right? So it's not a problem. It's not a problem. We will I'll post them so that and show you how you can attempt them, right? Then as well as question 5, these are the drawings. I'll also explain them on our comments on our community. So we need to look at them. So specifically in today's video, I will focus on question 3 and question 6. So the remaining question you can answer yourself. You can answer them for yourself individually. The theoretical part as well as the drawings. So due to time, I didn't have enough time because I was a little bit busy. So, but it's fine. I dedicated myself that let me do question 3 and question 6 because these are the questions that are tedious and that gives a lot of students a problem. So you can ace a distinction if you can listen very well, right? So we'll look at question 3 in this video. Then the next video will be about question 6. Let's go to question 3. So then they said, Tumisho claims that a triangle with sides 12 centimeter and 37 centimeter and 35 centimeter, it's a right angle triangle. Prove or disprove this claim. We need to prove or disprove this claim. How can we prove that? Let's put that into practice. Well, we are at question 3.1. Guys, we need to prove Tumisho's claim, right? First thing first, we will use the Pythagorean theorem, or what we call a Pythagoras theorem. The Pythagoras theorem states that r squared is equals to x squared plus y squared, right? Where x is our adjacent, so it has it will be 12 centimeter given them, and y it will be 37 centimeter. Then we also have r. Our y is 35 centimeter. Forgive me for that. Y should be 35, and our r, which is the hypotenuse part, the longest side will be 37, right? So that's why I named them alphabetically. So we are looking for what here? We need to prove. Actually, we are proving Tumisho's claim that this is a right triangle. So using a theorem of Pythagoras, r squared, which is equals to x squared plus y squared. R, guys, is given as 37 squared, and x is given as 12 squared, and y is given as 35 squared. So I'll punch this, guys. What is 12 squared? 12 squared, it's 144 plus 35 squared. That will be 1225. So we have 37 squared. We are actually proving that the left hand side will be equal to the right hand side. Then punch in your calculator 37 squared. It's the same as 37 times 37, which gives you 1369. Similarly, if I add 144 plus 1225, that will be 1069. Thus, the left-hand side is equals to the right-hand side. Well, Tumisho, then we write, Tumisho is correct. Tumisho's claim is correct. Then that's how we can, guys, work out the question 3.1, which had 5 marks, right? So you just have to listen very carefully and apply what is needed. So let's go to 3.2 now. At 3.2, we are given that in the diagram below, a circle with center O has the points R, Q, and P. On its circumference, the lines OP and OQ, they said the lines OP, where is O, OP, OQ. These are the radiuses, guys, ne? OQ and OP. No? Then we are being told that RP are drawn and OQ is perpendicular to RP. Yes, it forms 90 degrees here. Then they said at T we can see it's 90 degrees. OP is 10 units and TP is 8 units. Use the theorem of Pythagoras to calculate the value of QP, which means the value of X. So we are going to use theorem of Pythagoras. The best way, guys, to analyze such question is to know this is what we call theorem 1. Line from a center is perpendicular to the chord, and yeah, it's perpendicular to the chord because we can see at T it's 90 degrees. So what shall I do? Let's put that into practice. Well, remember, we are looking at 3.2. What is nice about this question? Collect the data first. You are given that TP is 8 units, and you're given that OP it's 10 units. Your goal is to find QP, which is X, right? So let me draw. You will forgive me about my drawing. It won't be that accurate as the sketch that is given there, but I'll try my best. I'm not good in drawing, but I'll try my best. So this is R, and okay, so for that, the cycle, sorry, as long as you can see, guys, this is O, and this is T, and it forms 90 degrees here, and we're being told X. This is the one we're looking for, Q and P. Yours will be accurate, guys. Yours will be accurate. Yours will be accurate. We're actually looking for QP. What is given? Let's check. We're given that TP it's 8 units. TP it's 8 units. And we are given that OP it's 10 units. 10 units. So what is missing? It's OT. We don't know OT. Let's put a question mark. So let's start with in triangle. I'm going to write in triangle OTP. In triangle OTP, we are going to use the theorem of Pythagoras. R squared plus y squared is equals to R squared. It's equals to R squared, right? What is our hypotenuse? Our hypotenuse here, it's the longest side, which is 10. So that will be 10 squared. What is our opposite? Is OT. So we'll put it where there's y. This is our opposite. When you're standing here, your opposite's here. So this is your adjacent side. So in other words, it's TP. Our TP, what is our TP? Our TP, it's 8. So it's going to be, so what is 8 squared? Punching, that will be 64 plus OT, which is equals to 10 squared is 100. And because I'm looking for OT squared, take 64 to the other side. It becomes 100 minus 64. So what is 100 minus 64? That is 36. So we have OT squared, square root. OT is 6 units. Thus, we now know that OT, it's what? It's 6. Sorry for that. OT is 6 units. So we haven't solved for QP. We haven't solved for QP. So to solve for QP, guys, you will have to be smart. If we can be able to find TQ, we can make our life easy. We can make our life easy. What we can see is that you can agree with me that OQ, it's a radius, and that OQ is equals to QP. Both of them are the radius. Let's do it in this manner. Let's see what we're getting. OQ is equals to OP. The reason, both of them are radi. If I do it in this manner, both of them are radius. So we call it, we write radi when supporting the statement. So since OP is 10, it means that both of them, OQ now will be 10 units. Will be 10 units. So what should I do now? So OQ, so remember, what forms OQ first? OQ is formed by OT. We can see OT and TQ plus TQ. Remember, the aim is to find TQ first here. So we know that OQ, it's 10, and that OT is 6 plus TQ. You take this 6 to the other side, it becomes 10 minus 6. TQ will now be, TQ will now be 4 units. 4 units. Which is true because when we say 6 plus 4, we get 10. So meaning that OQ is equals to OP, which is 10 units, right? We have already calculated TQ as 4. So we have another right triangle here. Remember here, it also forms 90 degrees. So this is a right triangle. So this is a right triangle. So our opposite side, it's 8. Then the hypotenuse will be our QP or PQ, right? So we're going to say QP squared, which is equals to TP. Right, let me just, so that I have enough space. It's equals to TP squared, which is our opposite, and our adjacent is TQ, which is going to be TQ here, TQ squared. So our QP, it's going to be X squared. Our TP is going to be 4 squared. And our TQ will be, TP it's 8, sorry for that. And our TQ it's 4. Let's see, what is 8 squared? 8 squared, that will be 64 plus 16. 64 plus 16, what do we get? We get 80. So what is the square root of 80? Square root of 80 will be 8,94. Okay, will be in 1 decimal places actually. That will be 8,9. 8,9 units. 8,9 units. In this manner, you can in this manner that's how it should be. But if we were to use another method, let's see. If I say that since I know that the TP is 8 units and that OT, so yep. Let me see. TP and Yeah, I guess this is it, guys. This is it. This is how you should have this. Yes, let me not guess. This is how you should answer such question at 3.2. Wow, such a question, right? So it needed us to apply whatever we know. Then we get that beautiful. Feel free to comment, and if I made a mistake, just tell me. Just tell me if I made a mistake. Just tell me, and we'll fix it, guys. Yes, guys. Yeah. That's how it should be. We have our x there as 8,9 units. So let's go to 3.3. At 3.3.1, we need to put that into practice. So how are we? At 3.3.1, state whether each of the following true or false. If the statement is false, illustrate with a drawing and why you say so. All parallelograms are trapezium. That's a lie. Actually, I was supposed to say false, not a lie. That's false. Then why I say so? Because a trapezium is one pair parallel. Not all, also not all parallelograms are. Not all parallelograms are trapezium. Yes, not all, because others have both sides parallel. No, so this one it's false, guys. So you can draw a trapezium. You can show that by drawing a trapezium. No. Then at 3.3.2, all triangles are rhombi. False again, because a rectangle, all rectangles are rhombi. A rectangle is 90 degrees in its corner. The corner angles are 90 degrees, while a rhombus, it's a different story. So we will need to draw a rhombus, right? Then at 3.3.3, all squares are kites. That's true. Square satisfies the definition of a kite. Yes, it satisfies it perfectly. So that's how you can answer that beautiful 16 marks. Feel free to comment. As always, there's always a room for learning. Hope, guys, you enjoyed this video, and I hope you have learned something vital that will help you tomorrow. Wishing you all the best. See you in the next video, which is our last video, question 6, where we'll look at trigonometry.